Welcome to unacademy. Let us crack GATE ESE. This is Umamaheshwara Rao. With up to 6 months free extension for GATE and ESE civil subscriptions. Join the Prarambh batch for GATE and ESE PSUs 2025. Batch commences from 31st January. Yeah, good afternoon Roshan. Good afternoon everyone. GATE ESE Civil, Electrical, ECE, Mechanical, Chemical and GATE CSIT. Save up to 50% off and 6 months free extension. 6 months free extension. Offer is valid till 27th January. Unacademy is announcing Prarambh batch for GATE ESE PSUs 2025. Batch commences from January 31st. Unacademy is announcing Vishwas batch for GATE and ESE PSUs 2026. Welcome to the revision course on engineering mathematics. Today our topic is probability and statistics. Unacademy is congratulating ESE 2023 top rankers. Unacademy is congratulating GATE 2023 top rankers. All India mock test for GATE. Get an exam like Aspirants for GATE 2024 on 28th January. The probability that a number is selected at random between 100 to 999 will not contain the digit 7. Will not contain the digit 7. Between 100 to 999 total how many numbers are there? Upper limit minus lower limit plus 1. $900. So it is a 3-digit number. There are 3 blank places. See, left extreme digit neither 0 nor 7 because do not contain 7. Here not 7. Here not 7. Remaining numbers you can fill. Here neither 0 nor 7 means 8 ways. Here not 7. 0 can be. That's why 9 ways. 9 ways. 81 into 8. These are favorable cases. Favorable cases are 648. The required probability is 648 by 900. That is 18 by 25. Therefore, correct answer is 18 by 25. Understood? Next problem. Seven car accidents occurred in a week. What is the probability that they all occurred on the same day? They all occurred on the same day. So, the total number of possible ways equal to 7 car accidents occurred in a week means first day 7 accidents may occur. So 7 car accidents may occur any one of the day. That's why total number of possible ways are, because accidents are independent. So since accidents are independent, Therefore, total number of possible ways are 7 power 7. Okay, na? Now, number of favorable cases. Sir, what is favorable case here? All these accidents may occur on the same day. That day could be Monday or Tuesday or Wednesday or Thursday or Friday or Saturday or Sunday. Therefore, 7 ways. Therefore, the required probability is 7 by 7 power 7, 1 by 7 power 6, 1 by 7 power 6, 1 by 7 power 6. Next problem. A bag contains 10 marbles, 20 black marbles, 30 red marbles. A marble is drawn from the bag and its color is recorded. It is put back in the bag. The process is repeated 3 times. That means the experiment is done with replacement. What is the probability that no 2 of the marbles are of same color? So all the marbles are of different color. Try this one. How many blue? 10 blue. How many black? 20 black. How many red? 30 red. The experiment is done with replacement. First, one blue marble is drawn. That is 10C1 by 60C1. One black marble is drawn. 20C1 by 60C1. One red marble is drawn. 30C1 by 60C1. Yeah. Sir, why you have written blue, black, red? Why not black, blue, red? Why not red, blue, black? So there are 3 factorial different procedures. 6 into 1 by 6 into 2 by 6 into 3 by 6. That is 1 by 6. The required probability is 1 by 6. The required probability is 1 by 6. In a game, there are 2 players. X and Y are tossing coin alternatively. Whoever gets head first wins the game. The game is terminated. Find the chance that player X wins the game if he starts the game. So if X starts the game, what is the chance that X wins the game? That is the problem. So now, if X starts the game, what is the chance that X wins the game? See, first X starts. If X fails to get head, chance will go to Y. If Y fails to get head, chance will come to X. If X fails to get head, chance will go to Y. If Y fails to get head, chance will come to X. Now, winning chance of player X. First throw X wins. First throw X fails. Second throw Y fails. Third throw X has a chance to win. First throw X fails. Second throw Y fails. Third throw X fails. Fourth throw Y fails. Fifth throw X has a chance to win. Like that. First throw X has a chance to win 1 by 2. Fails 1 by 2. Y fails 1 by 2. X fails, X success 1 by 2. 1 by 2 into 1 by 2 into 1 by 2 into 1 by 2. Chance to get head or chance to get tail, both are same. No, that's why. Let us take 1 by 2 common. 1 plus 1 by 4 plus 1 by 4 square plus and so on. A by 1 minus R. 1 by 2 into 1 by 3 by 4. 1 by 2 into 4 by 3, that is 2 by 3. Winning chance of X is 2 by 3. Winning chance of X is 2 by 3. A box contains chips numbered 3, 6, 9, 12, 15. And box 2 contains 6, 11, 16, 21, 26. The number is written on the chips are multiplied. What is the probability that product is even number? Three, 6, 9, 12, 15. Box 2 contains 6, 11. 6, 11, 16, 21, 26. Now, the product is even number. Observe here. Two chips are selected, one from each box. One chip is drawn from box 1, another chip is drawn from box 2. One chip is drawn from box 1 and another chip is drawn from box 2. Now, even number from box 1, even number from box 2 are even from box 1, odd from box 2. Odd from box 1, even from box 2. Even number from box 1, 2C1. Even number from box 2, 3C1. R means plus. Even from box 1, 2C1. Odd from box 2, 2C1. Even from box 1, 2C1. Odd from box 2, 2C1. Odd from box 1, 3C1. Even from box 2, 3C1. That is 6 plus 4 plus 9 by 25. 6 plus 4 plus 9 by 25. 19 by 25. Next one. A and B are friends. They decide to meet between 1 p.m. to 2 p.m. on a given day. There is a condition that whoever arrives first will not wait for the other more than 15 minutes. The probability that they will meet on the day is, they will meet on the day is, I am going to record B arrival time on vertical line, A's arrival time on horizontal line. The condition is given that whoever arrives first will not wait for the other more than 15 minutes. Now, whoever arrives first will not wait for the other more than 15 minutes. Observe here. Suppose A arrives at 1 o'clock, he will wait for B up to 1:15. A arrives at 1:15, he will wait for B up to 1:30. A arrives at 1:30, he will wait for B up to 1:45. A arrives at 1:45, he will wait for B up to 2 o'clock. Similarly, B arrives at 1 o'clock, he will wait for A up to 1:15. B arrives at 1:15, he will wait for A up to 1:30. B arrives at 1:45, he will wait for A up to 2 o'clock. That's why this is favorable area for A and B to meet on the day between 1 p.m. to 2 p.m. See, this is favorable area. To calculate favorable area, we have to integrate. That's why what I am doing, I am going to calculate non-favorable area. Sir, calculation of non-favorable area is very easy for us because this is non-favorable area, na? Blue color one, this part. Not only that, but also this one. Calculation of non-favorable area is very easy because it is looking like right angle triangle. That's why the required probability is one minus non-favorable area by area of sample space. Non-favorable area, half into base into height. How many times? 2 times, because 2 right angle triangles we have, by area of the sample space 60 into 60. 1 minus 3 by 4 into 3 by 4. 1 minus 9 by 16. That is 7 by 16. Final answer is 7 by 16. Understood? Next problem. What is the probability that a divisor of 10 power 99 is a multiple of 10 power 96? A divisor of 10 power 99 is a multiple of 10 power 96. First I am going to calculate divisors of 10 power 99. I am using prime factorization method. 2 power 99 into 5 power 99 is 10 power 99. The total number of divisors equal to 99 plus 1 into 99 plus 1, 100 into 100, 10,000. Total 10,000 divisors. See, 10 power 96 into 1 is 10 power 96. 10 power 96 into 2. 10 power 96 into 1000 equal to 10 power 99. Total you have 1000 multiples. In these 1000 multiples, only 16 multiples are divisors of 10 power 99. Sir, how can you say that only 16? Simple. Observe. 10 power 99 by 10 power 96 into k. 10 power 99 can be written as 10 power 96 into 1000 by 10 power 96 into k. 10 power 96, 10 power 96 cancel. If k divides 1000, automatically 10 power 96 into k is a divisor of 10 power 99. So our job is to calculate divisors of 1000. Okay na? 1000 can be written as 2 power 3 into 5 power 3. Okay na? That's why divisors of 1000 equal to 3 plus 1 into 3 plus 1. Prime factorization method. That is 16. So total there are 16 divisors for 1000. Therefore, total there are 16 multiples are divisors of 10 power 99. Therefore, the required probability is, therefore, the required probability is 16. What are these 16? Multiples of 10 power 96 and divisors of 10 power 99 by 10,000. That is 1 by 625. 1 by 625. Understood? The probability that a student knows the correct answer to a multiple choice question is 2/3. If the student does not know the answer, then the student guesses the answer. The probability of guessed answer being correct is 1 by 4. Given that the student has answered the question correctly, the conditional probability that the student knows the correct answer is knows the answer, guesses the answer. Both are mutually exclusive. In the data it is given that a student knows the answer to a multiple choice question is 2/3. Knows the answer 2/3 means guesses the answer is 1/3. Answer correct is an arbitrary event. Correct is an arbitrary event. If the student knows the answer, it is 100% correct. If the student guesses the answer, the guessed answer being correct is given by 1 by 4. That is given in the data. The guessed answer being correct is 1 by 4. That's why. Now, if the student has answered the question correctly, if the student has answered the question correctly, what is the chance that he knows? That is 2/3 into 1 by 2/3 into 1 plus 1/3 into 1/4. 1/3 into 1/4. LCM 12. 3 4 ya 4 2 ya 8 plus 1. 2 by 3 into 12 by 9. Final answer is 8 by 9. Final answer is 8 by 9. An automobile plant contracted to buy shock absorbers from two suppliers X and Y. X supplies 60% and Y supplies 40% of the shock absorbers. All the shock absorbers are subjected to a quality test. The ones pass the quality tests are considered reliable. Out of X shock absorbers, 96% are reliable, Y shock absorbers 72% are reliable. The probability that randomly selected shock absorber which is found to be reliable is made by Y. Is made by Y. It is a problem on Bayes theorem. %60%. X supplies 60%. Y supplies 40% of the shock absorbers. Reliability is an arbitrary event. Reliability is an arbitrary event. 96% of the shock absorbers supplied by X are reliable. 72% of the shock absorbers supplied by Y are reliable. If a shock absorber found reliable is supplied by Y, 0.40 into 0.72 by 0.40 into 0.72 plus 0.60 into 0.96. Simplify this. .334. Next problem. The chance of a student passing in an examination is 20%. The chance that student passing the exam and getting off above 90% is 5%. So it is a problem on conditional probability. We have to calculate the student passes the exam and getting off above 90% is 5% by 20%. That is 1 by 4. That is 1 by 4. P and Q are considering to apply for a job. The probability that P apply for the job is 1 by 4. The probability that P apply for the job given that Q apply for the job is 1 by 2. Probability of P by Q is 1 by 2. Probability of Q by P is 1 by 3. From here you can write Q intersection P by probability of P is 1 by 3. Probability of P intersection Q is 1 by 12. Next. Probability of P by Q is 1 by 2. Probability of P by Q is 1 by 2. P intersection Q is 1 by 12. Probability of P by Q is 1 by 6. Next. Probability of P plus probability of Q minus probability of P intersection Q is 1 by 4 plus 1 by 6 minus 1 by 12. One by 3. Next, we have to calculate probability of P dash by Q dash. Probability of P dash intersection Q dash by probability of Q dash. Probability of P union Q dash by probability of Q dash. 1 minus probability of P union Q by 1 minus probability of Q. P union Q is 1/3. Probability of Q is 1 by 6. Two by 3 by 5 by 6. 2 by 3 into 6 by 5. That is 4 by 5. Final answer is 4 by 5. A pair of dice is rolled again and again till a total of 5 or 7 is obtained. The chance that a total of 5 comes before a total of 7 is. A pair of dice is rolled again and again till a total of 5 or 7 is obtained. The chance that a total of 5 comes before a total of 7. See, it is a game between 5 or 7. Your job is to calculate winning chance of 5. Here 5 and 7 are not numbers, they are sums. Okay na? So whenever sum 5 or sum 7 comes, you are going to stop the game. If 1 4 comes, 2 3 comes, 3 2 comes, 4 1 comes, 1 6 comes, 2 4 come, not 2 4, 2 5 comes, 3 4, 4 3, 5 2, 6 1. In all these 10 cases, you are going to stop the game. In the 10, how many are favorable to sum 5? 4 cases. That's why the required probability is 4 by 10. That is nothing but 2 by 5. The required probability is 2 by 5. Bag P contains 3 white, 4 black. Bag Q contains 4 white, 3 black. A ball is transferred from bag P to bag Q. Then a ball is transferred from Q to P. A ball is taken out from bag P. Then the chance that it is white. Observe. Bag P contains 3 white, 4 black. 4 white, 3 black. One ball is transferred from P to Q. Did they mention the color? No. One ball is transferred from Q to P. Later one ball is selected from P. What is the chance that it is white? That is our problem. Okay na? Now first transfer could be white or black. Second transfer could be white or black. That's why total 4 possible combinations. White, 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 black, black, white, black, black. These are the different possible combinations. Any third selection is white. You have to select white ball from bag P later. These are the different possible combinations. First, 3 white, 4 black, 4 white, 3 black. Suppose first we have transferred white ball from P to Q. Chance of transferring white ball from P to Q, 3C1 by 7C1. Now 3 white become 2 white, 4 white become 5 white. Next, second transfer is white. That's why second transfer is white. Chance of transferring white from Q to P, 5 by 8. 5 becomes 4. After transferring, 2 becomes 3. Now select white ball from P, 3 by 7 plus P, Q. 3 white, 4 black, 4 white, 3 black. White ball is transferred from P to Q, so 3 by 7. Yeah, white ball is transferred, 3 becomes 2, 4 becomes 5. Next, black ball is transferred from Q to P. 3 by 8 transferred. 3 becomes 2 black. 4 becomes 5 black. Next, white ball is selected from P. 2 by 7 plus P, Q, 3 white, 4 black, 4 white, 3 black. Select black ball from P. 4 by 7. 4 becomes 3. 3 becomes 4. Chance of getting white ball from Q. 4 by 8. 4 becomes 3. 3 becomes 4. Chance of getting white from P. 4 by 7. R means plus. 3 white, 4 black, 4 white, 3 black. Chance of getting black, 4 by 7. Chance of getting black, 4 by 8. Chance of getting white, 3 by 7. Now, denominator is 392. Numerator 5 3 15, 15 3 45. 3 3 9, 9 2 18. 64. 48. That is nothing much. One 75 by 392. 725 is 756. Next problem. There are two identical locks with two identical keys. The keys are among 6 different ones, which a person carries in his pocket. In hurry, he drops one key somewhere. Then the probability that the locks can still open by drawing one key at random. There are two identical locks with two identical keys. The keys are among 6 different ones, which a person carries in his pocket. In hurry, he drops one key somewhere. One key is dropped somewhere. That key could be different or could be identical. Dropping different 4 by 6. Dropping identical 2 by 6. From 4 different, 1 different is lost. So 3 different are left, 2 identical are left. From 2 identical, 1 identical is left. So 1 identical is there, 4 different are there. Now Select identical key. Select identical one. Select identical one. 2 by 5. 1 by 5. So 4 by 6 into 2 by 5. 2 by 6 into 1 by 5. 8 by 30. 2 by 30. Add both. That is 10 by 30. So 1 by 3. The required probability is 1 by 3. A party of n persons takes their seats at random at a round table. Then the probability that two specified persons do not sit together. Two specified persons do not sit together. Two specified persons do not sit together. N persons takes their seats at random at a round table. Because of round table, n persons can be arranged n minus 1 factorial ways. From n persons, you have to separate 2 persons, remaining n minus 2. These 2 persons should be in one unit, because first I am calculating they must be together. Remaining n minus 2. n minus 2 plus 1 is n minus 1. These n minus 1 units can be arranged at a round table n minus 2 factorial ways. In this one unit, there are two people. Two people are in one unit. They can be arranged 2 factorial ways. The probability that they sit together is given by two factorial into n minus 2 factorial by n minus 1 factorial 2 by n minus 1. Probability that they do not sit together is given by 1 minus 2 by n minus 1 n minus 1 minus 2 n minus 3 by n minus 1 final answer is n minus 3 by n minus 1. The letters of the word probability are arranged in all possible ways. The chance that B's and also I's occur together is, first you have to arrange the letters of the word probability in all possible ways. How many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 letters can be arranged 11 factorial ways, but all 11 are not different. In that 11, 2 B's, 2 factorial, 2 I's, 2 factorial. These are total number of possible ways. Now, favorable cases. What are favorable cases here? B and B should be together. I and I should be together. That's why take one thread, bond them. This is 1 unit, remaining 7 units. Total 9 units. 9 units can be arranged in a row, 9 factorial ways. The required probability is 9 factorial into 2 factorial into 2 factorial by 11 factorial. That is 2 into 2 by 11 into 10. That's why correct answer is 2 by 55. 2 by 55 is the correct answer. From 6 positive and 8 negative numbers, from 6 positive and 8 negative numbers, how many numbers are drawn? 4 numbers are drawn without replacement and multiplied. 4 numbers are drawn without replacement and multiplied. The probability that the product is a positive number. 6 positive, 8 negative numbers. There are 6 positive and 8 negative numbers. Now, the product is positive. From 6 positive and 8 negative numbers, 4 numbers are drawn. What is the chance that the product is positive? If all 4 are positive, then the product is positive. If all 4 are negative, then the product is positive. Or 2 positive and 2 negative, then the product is positive. Okay na? Now, all 4 positive means 64. All 4 negative means 8C4. 2 positive, 2 negative means 6C2 into 8C2. Simplify this. 505 by 1001 is the correct answer. 505 by 1001 is the correct answer. 2 squares are selected at random from a chessboard. What is the chance that they have a side in common? What is the chance that they have a side in common? Observe here. Total there are 64 squares. From 64, 2 are selected. Now, from 64, 2 are selected. Now, one common side, second common side, third common side, fourth, fifth, sixth, seventh. 7 in one column. Yeah, I have selected 2 adjacent squares in a row. I got one common side. Okay, na? There are 8 columns. How many column side? How many common sides? 56. Similarly, row wise, between these 2 columns, there is one common side. Second, third, fourth, fifth, sixth, seventh. 7 common sides in one row. There are 8 rows. So row wise 56, column wise 56. That's why 112 by 64 into 63 by 2 into 1, 232s. 16 2 ja 32, 16 7 ja 112, 7 1 7 9s, that is 1 by 18 is the required probability. Next, a sample of 15 data is as follows. So what is mode of the data? Mode means maximum frequency point. See, 17 has maximum frequency. How many times it is appeared? 4 times. That's why 17 is the mode of the data. Therefore, what is mode of the data? 17 is mode of the data. Understood? Next problem. A random variate has the following distribution. A random variate has the following distribution. What is the value of k? So first we have to add sum of all probability mass functions. First we have to add sum of all probability mass functions. Sigma p of x equal to 1. Zero plus k plus 2k plus 2k plus 3k. K square plus 2k square plus 7k square plus k. Now 9k square plus k plus 3k, 4k, 7k, 9k, 10k equal to 1 or minus 1 equal to 0. One minute. 10k square. Sorry, this is 10k square. Seven plus 2 9, 9 plus 1 10k square. K plus 2k 3k, 3k plus 2k 5k, 5k plus 3k 8k, 8k plus k 9k. This is 9. Now 10k square plus 10k minus k minus 1. Now if you take 10k common, k plus 1 minus 1 common, k plus 1, therefore k plus 1 into 10k minus 1 equal to 0, therefore k equal to minus 1 or k equal to 1 by 10. 1 by 10 is nothing but 0.1. So k equal to 1 by 10 is considered. K equal to minus 1 is neglected. Neglect. Understood? So 0.1 is the correct answer. Yes, Krishna. Very good. A random variable x takes values 1, 2, 3 with probabilities 2 plus 5p by 5, 1 plus 3p by 5, 1.5 plus 2p by 5. Then the value of p and e of x respectively. See, sum of all probability mass functions equal to 1. That's why 1 plus 2p by 5, sorry, 1 plus 3p by 5. 2 plus 5p by 5 1 plus 3p by 5 equal to 1. P equal to 0.05. The value of P is 0.05. Next we have to find out E of X. Expectation of X is 1 into 2 plus 5p by 5. Two into 1 plus 3p by 5. Plus 3 into 1.5 plus 2p by 5. That is 8.5 plus 17 into P by 5. That is 1.87. 0.05 comma 1.87. So first option is correct. Next problem. Each of the 9 words of a sentence, the quick brown fox jumps over the lazy dog. The quick brown fox jumps over the lazy dog. The quick brown fox jumps over the lazy dog is written on a separate piece of paper. Observe. How many letters are here? 3. Here 5. 5. 3. 5. Here number of letters is nothing but length of the word. This is 4. 3. 4. 3. So here length is the random variable. which takes values 3, 4, 5. Length takes only 3 values. Three, 4, 5. Length takes value 3. In how many cases? 1, 2, 3, 4. 4 cases out of 9. Length is 4. In how many cases? 2 cases out of 9. Length is 5 in 3 cases out of 9. The required, we have to calculate expected length. Sigma x into p of x. 3 into 4 by 9. 4 into 2 by 9 plus 5 into 3 by 9 12 plus 8 plus 15 by 9 35 by 9 3.88. The required probability is 3.88. Next problem. Passengers try repeatedly. Passengers try repeatedly to get seat reservation in any train running between 2 stations until they are successful. 40% chance of getting reservation in any attempt by the passenger. Then average number of attempts required by the passenger to get seat reserved. So here number of attempts is the random variable. Random variable counts number of attempts. Number of attempts 1, 2, 3, 4. Number of attempts equal to 1 if you get success in the first attempt. Number of attempts are 2. First attempt failure, second attempt success. Number of attempts are 3. 2 times failure, 1 time success. Number of attempts are 4. 3 times failure, 1 time success. Like that. Expected number of attempts 1 into 0.4, 2 into 0.6 into 0.4, 0.6 whole square into 0.4 and so on. 0.4 of 2 into 0.6, 3 into 0.6 whole square and so on. Now 0.4 into 1 minus 0.6 whole power minus 2. 1 minus 0.6 is 0.4 whole power minus 2. 4 by 10 into 10 by 4 whole square. 10 by 4. That is 2.5. So final answer is 2.5. A man takes a step forward with probability 0.4, backward with probability 0.6. If the person takes at the end of 11 steps, he is one step away from the starting point is. See here, number of trials are 11. X counts forward. P is 0.4. Q is 0.6. If the person takes 5 steps backward, 5 steps forward, 6 steps backward, or 6 forward, 5 backward, then he is one step away from the starting point. So we have to calculate probability of x equal to 5 or probability of x equal to 6. NC5 p power 5 q power n minus 5 plus NC6 p power 6 q power n minus 6. That is 11C5 0.4 whole power 5 0.6 whole power 6. 11C6 0.4 whole power 6 0.6 whole power 5. That is 0.4 whole power 6 0.6 whole power 5. Continuation. Zero 0.6 plus 0.4. 462 into 0.24 whole power 5 into 1. 462 into 24 by 100 whole power 5. 462 into 6 by 25 whole power 5. An unbiased coin is tossed infinite number of times. An unbiased coin is tossed infinite number of times. An unbiased coin is tossed infinite number of times. What is the probability that fourth head appears at the 10th toss? Fourth head appears at the 10th toss. That means 10th toss you have to get head. That head must be fourth head. When you can say this head is fourth head, in the previous 9 trials, if you get already 3 heads, we have to get exactly 3 heads. Now probability of x equal to 3, NC3, P power 3, Q power 9 minus 3. Into probability of getting head is 1 by 2 in 10th toss. So finally 9C3 by 2 power 10, 84 by 1024, 0.082. So correct answer is 0.082. The number of accidents occurring in a plant in a month follows the number of accidents occurring in a plant in a month follows Poisson distribution with 5.2. What is probability of occurrence of 2 accidents in a plant in a randomly selected month? So lambda is equal to 5.2. Now probability of occurrence of less than 2 accidents. Probability of x equal to 2. Probability of x equal to 0 plus probability of x equal to 1. E power minus lambda into lambda power 0 by 0 factorial. E power minus lambda into lambda power 1 by 1 factorial. E power minus lambda of 1 plus lambda. E power minus 5.2 of 1 plus 5.2. That is 0.062. No. Actually 0.034 this is. Okay na? 0.034. Next point. It is estimated that the average number of events during a year are 3. What is the probability of occurrence of not more than 2 events over a 2-year duration? Two-year duration means 6 events. Problem is designed for 2-year duration, therefore lambda equal to 6. Not more than 2, so greater than 2. Not greater than 2 means x less than or equal to 2, x equal to 0, x equal to 1, x equal to 2. That is e power minus lambda into lambda power 0 by 0 factorial, e power minus lambda into lambda power 1 by 1 factorial, lambda square by 2 factorial. 1 plus lambda square by 2, 1 plus 6 plus 36 by 2, 25 into e power minus 6, 0.062. A manufacturer knows that the condensers he makes contain on an average 1% of defectives. On an average 1% of defectives. He packs them in boxes of 100. What is the probability that a box picked up at random will contain 3 or more than 3 faulty condensers? It is a problem designed on limiting case. N is 100. P is 1%. Whenever N is large and P is very, very small, binomial mean NP and Poisson mean lambda both are equal. So lambda equal to NP. That is 1. Now we have to calculate probability of X will contain 3 or more than 3. 3 or more than 3. X is greater than or equal to 3. Instead of calculating greater than or equal to 3, it is better to calculate 1 minus probability of X less than 3. Probability of X equal to 0 plus X equal to 1 plus X equal to 2. 1 minus e power minus lambda into lambda power 0 by 0 factorial. E power minus lambda into lambda power 1 by 1 factorial. E power minus lambda into lambda square by 2 factorial. 1 plus lambda square by 2. Lambda is 1. 1 minus e power minus 1 of 1 plus 1 plus 1 by 2. 4 plus 1, 5 by 2 into E inverse. 1 minus 5 by 2 into E inverse. An observer counts 240 vehicles per hour at a specific highway location. 240 vehicles per hour at a specific highway location. See, per 1 minute how many vehicles? 4 vehicles. 60 seconds. 4 vehicles. 30 seconds. 2 vehicles. Therefore, lambda equal to 2. Therefore, lambda equal to 2. Now we have to calculate probability of having one vehicle. E power minus lambda into lambda power 1 by 1 factorial. E power minus 2 into 2 by 1 factorial. 2 by e square. 0.27. Understood? So correct answer is 0.27. Next problem. In this problem, a random variable x has Poisson distribution with mean 5. Lambda equal to 5. Variance of x is expectation of x square minus expectation of x whole square. Lambda is equal to expectation of x square minus lambda square. 5 is equal to expectation of x square minus 25. Therefore, expectation of x square is 30. Now expectation of x plus 2 whole square is x square plus 4x plus 4. Expectation of x square plus 4 into expectation of x plus 4. Expectation of x square is anyhow 30. Expectation of x is 5 plus 4. 30 plus 20 plus 4. That is 54. Expectation of x plus 2 whole square is 54. The variance of a random variable x with the probability density function f of x is 1 by 2 mod x into e power minus mod x. Yeah, we have to calculate variance of the given function. Understood? Now to calculate variance, first you have to calculate expectation. Expectation of 1 by 2 into mod x into e power minus mod x dx. It is odd function. It is odd function. Therefore, the value of integral is 0. Next, expectation of x square is minus infinite to infinite x square into 1 by 2 into e power mod x into e power minus mod x dx. It is even function. Therefore, we can write 2 times of 0 to infinite x square into 1 by 2 into x into e power minus x dx. 2 cancel. Therefore, expectation of x square is 0 to infinite e power minus x into x cube dx. X power 4 minus 1 dx. Gamma 4, that is 6. Therefore, variance of x is expectation of x square minus expectation of x whole square. Expectation of x is 0. Finally 6. Variance of x is 6. Next problem. The probability density function of a random variable is given as, then what is the value of a? Probability density function is given means here f of x is a into e power 4x when x less than 0. 3 by 2 into e power minus 3x when x greater than 0. Now we have to calculate the value of a, and another one, probability of x less than or equal to 0. We have one property, integral minus infinite to infinite f of x dx equal to 1. integral minus infinite to 0 a into e power 4x dx plus 0 to infinite 3 by 2 into e power minus 3x dx equal to 1. That is a into e power 4x by 4 from minus infinite to 0 plus 3 by 2 into e power minus 3x by minus 3 from 0 to infinite equal to 1. E power 0 is 1, e power minus infinite is 0, 3 3 cancel. E power minus infinite 0, e power 0 is 1. A by 4 plus 1 by 2 equal to 1. A by 4 equal to 1 by 2. A equal to 4 by 2, that is 2. The value of A is 4 by 2, that is 2. Next, probability of x less than or equal to 0 is integral minus infinite to 0 2 into e power 4x dx 2 by 4 of 1 minus 0, that is 1 by 2. 2 comma 1 by 2 is the correct option. Two comma 1 by 2 is the correct option. Next problem. A random variable x having probability density function shown in the figure. What is probability density function? 1 by 4 when x varies from minus 1 to 3. Minus 1 to 3. Otherwise 0. Okay. Now we have to calculate mean and variance. Integral minus 1 to 3 x into f of x dx 1 by 4 into x square by 2 from minus 1 to 3 1 by 8 of 9 minus 1 8 by 8 is 1 expectation of x is 1 expectation of x square is minus 1 to 3 x square into 1 f of x dx 1 by 4 into x cube by 3 minus 1 to 3 1 by 12 of 27 minus of minus 1 28 by 12 4 7 ja 4 3 ja variance of x is expectation of x square minus expectation of x whole square 7 by 3 minus 1 4 by 3 that is 1.33 1.33 variance of x is 1.33 and mean is 1 and 1.33 a random variable x has the probability function k into x power n into e power minus x k into x power n into e power minus x, then what is the value of k and n? Integral 0 to infinite integral 0 to infinite k into x power n into e power minus x dx equal to 1. Integral 0 to infinite e power minus x into x power n plus 1 minus 1 dx equal to 1. K into gamma n plus 1 equal to 1. K into n factorial equal to 1. K is 1 by n factorial. The value of k is 1 by n factorial. Next. Mean is 3. Expectation of x is 3. K into x power n. X power n plus 1 into e power minus x dx equal to 3. K into integral 0 to infinite e power minus x into x power n plus 2 minus 1 dx equal to 3. K into gamma n plus 2 equal to 3. K into n plus 1 factorial equal to 3. K equal to 3 by n plus 1 factorial. Here k is equal to 1 by n factorial. Here 3 by n plus 1 factorial. Now from this we can write 3 by n plus 1 factorial equal to 1 by n factorial. 3 equal to n plus 1 factorial by n factorial. 3 equal to n plus 1, therefore n equal to 2. The value of n is 2. Since n is 2, the value of k is 1 by 2 factorial 1 by 2. K is 1 by 2, n is 2. K is 1 by 2, n is 2. Third option is correct. Understood? Next problem. A point is randomly selected with uniform probability in xy plane within the rectangle. Okay, if P is the length of the position vector of the point, then expected value of P square is y-axis, x-axis. This is the rectangle. They have given the points 0, 0, 1, 0, 1, 2, 0, 2. P is the length of the vector. Now x varies from 0 to 1, y varies from 0 to 2. Next, P is x square plus y square under root P square is x square plus y square. Expected value of P square is expected value of x square plus y square. Expectation of x square plus expectation of y square. 0 to 1. X square into f of x dx. 0 to 2. Y square into f of y dy. Integral x square dx is x cube by 3. From 0 to 1. 1 by 2 into y cube by 3 from 0 to 2. One by 3 plus 1 by 2 into 8 by 3. 1 by 3 plus 4 by 3, that is 5 by 3. Answer is 5 by 3. Next. A random variable is uniformly distributed over the interval 2, 10. Then its variance will be. What is its variance? Simple. In uniform distribution, variance of x is given by beta minus alpha whole square by 12. Beta value 10. 10 minus 2 whole square by 12. 8 square, 64 by 12. 4 16s, 4 3 are 16 by 3 is the answer. 16 by 3 is the answer. Suppose you break a stick of unit length at a point chosen uniformly at random. What is the expected length of the shorter stick? Because of that word shorter, we can write x varies from 0 to half. Because if length of the stick is less than 50%, then you can treat that is shorter one. So to decide whether the stick is shorter or not, our reference point is 50%. That's why x varies from 0 to half. F of x is 1 by beta minus alpha. That is 1 by 1 by 2 is 2. Now, expectation of x is 0 to half x into f of x dx. 2 into x square by 2 from 0 to half. 2 to cancel. Finally 1 by 4. That is 0.25. Now, expectation of x is 0.25. Next. Here the problem is f of x is 1 by 5 into e power minus x by 5. For x greater than or equal to 0, what is the chance that the conversion will exceed 5 minutes? Exceed 5 minutes means x greater than 5. 5 to infinite f of x dx. That is e power minus x by 5 by minus 1 by 5 from 5 to infinite. 1 by 5, 1 by 5 cancel. E power minus infinite is 0. E power minus 5 by 5 is e power minus 1. Finally, e power minus 1. That is 1 by e. That is 1 by e. A random variable x following normal distribution with mean 100. Probability of x greater than or equal to 110 is alpha. Probability of 90 less than x less than 110 is. Probability of x greater than or equal to 110 is alpha. This part is alpha. Sir, if x greater than or equal to 110 is alpha, normal curve is symmetrical about its mean. Therefore, probability of x less than or equal to 90 is also alpha. Because if you fold the graph along mean line, this is x equal to 90. So whatever area beyond 110 you have, same area you will have beyond 90. If that part is alpha, this part is also alpha. Therefore, probability of 90 less than x less than 110 is 1 minus 2 alpha. 1 minus 2 alpha. Understood? Next problem. The standard normal probability function can be approximated by this function. So here mean is 1 or 2. Standard deviation is 27. What is the probability that annual precipitation lies between 90 to 1 or 2? That is x equal to mu. This is mu plus sigma. This is mu minus sigma. Mu plus sigma is 129. Mu is 102. Mu minus sigma is 75. The area between 75 to 129 is 68%. Sir, if 75 to 129 is 68%, 75 to 102 is 75 to 102. Mu minus sigma to mu na 34% na. Therefore, probability of 90 less than x less than 102 is probability of 90 less than x less than this is mu minus sigma, this is mu plus sigma. Mu minus sigma to mu plus sigma is 68%. Now 90 to 102, this is 90. 90 to 102. Observe this part. What about that part? That is, in the options, they have given 66.7% no, 50% no, 33 no, 16.7% is correct. Understood? Next problem. X be a normal variate with mean 1 and variance 4. Mean is 1, variance 4. Mu x is 1. Sigma square x is 4. sigma mu y is -1. Sigma y is unknown. Probability of x less than or equal to -1 is equal to probability of y greater than or equal to 2. I am going to convert both the random variables into standard normal variate. Z less than or equal to -1 minus 1 by 2. Z greater than or equal to 2 minus of -1 by sigma. Z less than or equal to -1 is Z greater than or equal to 3 by sigma. By the property of normal curve is symmetric. Therefore, probability of Z less than or equal to -1 you can convert into Z greater than or equal to 1. Whatever area beyond -1 and the area beyond 1 both are same. Therefore, 1 equal to 3 by sigma. Therefore, sigma equal to 3. Finally, sigma equal to 3. Next problem. U and V be two independent zero mean Gaussian random variables with mean zero mean. So mean of U is 0, mean of V is 0. Expectation of U is 0, expectation of V is 0. Sigma variance of V, sigma square V is 1 by 4. Sigma square U is 1 by 4. Sigma square V is 1 by 9. Our job is to calculate probability of 3V minus 2U. Let us take T is 3V minus 2U. Expectation of T is expectation of 3V minus expectation of 2U. 3 into expectation of V minus 2 into expectation of U. 3 into 0 minus 2 into 0. Finally 0. Expectation of T is 0. Now we have to calculate probability of 3V minus 2U less than or equal to 0. Probability of T less than or equal to 0. Here U follows normal distribution, V follows normal distribution, T also follows normal distribution. This is mean line. Okay na? Now T less than or equal to 0 means which part? Expectation of T is 0. Mean of T is 0. When mean of T is 0, probability of T less than 0 means left side part of T equal to 0. This is T equal to 0. Therefore half, 50%. Understood? Next one. A continuous real valued random variable defined over the interval minus infinite to infinite. Here f of x is 1 by b root t pi. F of x is 1 by b root pi into e power minus 1 by 2 of x minus b by 2 whole square, b root 2 pi, sorry, b root 2 pi. Now we have to calculate. See, from the function you can understand that mean is a, sigma is b, standard deviation is b. Therefore, generally normal curve is a bell-shaped curve. Normal curve is symmetrical about its mean. What we have to calculate in this problem? In the problem it is given that our job is to calculate minus infinite to a. One by b root 2 pi e power minus 1 by 2 of x minus b by x minus a by b whole square dx. We have to calculate this value. Please observe. This is mean line, x equal to a. This is minus infinite. So from minus infinite to a, f of x dx is nothing but this area. Na? This area is nothing but area under the normal curve from minus infinite to a. Left side of a, it is 0.5. So the answer is 0.5. Understood? Next one. Understood? Right. Karnakar, please post the question. Karnakar. Okay. Tomorrow I am going to conclude this revision course.